In the mid-1990s, NASA believed it was on the edge of something extraordinary. Not a new shuttle, not a new engine, but a new kind of spacecraft. One that could take off vertically, reach orbit in a single stage, land on a runway like a plane, refuel, and fly again. No boosters, no staging, no discarded metal raining back to Earth. A true, reusable space vehicle. It was called the X-33 VentureStar, and for a moment, it looked like the future of space travel had finally arrived. A spacecraft that could fly to orbit the way airliners fly across the world. Cheap, fast, reusable. It wasn't science fiction, it was being built. Metal, engines, prototypes, a real program. And then, suddenly, quietly, it was canceled. A project once hailed as the successor to the Space Shuttle was erased before it ever left the ground. This is the story of the rocket that could have changed everything, and the future NASA walked away from. Welcome to Missed Futures, the series where we explore the ideas that came too early and the engineers who saw tomorrow long before the world was ready to believe it. Because sometimes the future isn't lost to failure. Sometimes it's lost to fear, politics, and timing. And nothing captures that more perfectly than the rise and fall of the X-33 VentureStar. The dream of a reusable spaceship didn't start in the 90s. It goes back decades, even before the Space Shuttle. Engineers had always wanted a single stage-to-orbit vehicle, or SSTO. A spacecraft that launches like a rocket but lands like a plane. One vehicle, one piece. No discarded boosters, no ocean recovery. Something elegant, something efficient, something inevitable. But for decades, it was impossible. The materials were too heavy, the engines weren't efficient enough. The math didn't close. Then came the 1990s, a new era of aerospace materials, new simulations, new manufacturing. Suddenly, SSTO didn't feel impossible anymore, just difficult. NASA launched a program called the Reusable Launch Vehicle Initiative, a push to build a fully reusable ship that could replace the aging Space Shuttle. Lockheed Martin proposed a wedge-shaped craft with metallic skin, advanced lightweight composites, and a revolutionary engine system. A vehicle that could take off vertically, reach orbit in a single stage, land on a runway like a plane, refuel, and fly again. NASA bought the vision. Lockheed Martin won the contract, and the project was named the X-33, the demonstrator for a full-scale system called VentureStar. The excitement was real. Congress supported it, the president supported it, NASA poured money into it, Lockheed Martin began building it. For perhaps the first time in history, humanity was building a spacecraft that looked like the future instead of the past. The X-33 was radical. It used cutting-edge composite cryogenic fuel tanks light enough to make SSTO possible. It used an AEROSPIKE engine, a design that had existed on paper for decades but never flown. The shape was unorthodox, a wedge with curved lifting surfaces. Not a cylinder, not a shuttle, something entirely new. If it worked, the VentureStar would have cut launch costs by 80%. Flights that cost hundreds of millions of dollars would cost tens of millions. Suddenly, space wouldn't be a rare event. It would become routine. And deep inside NASA, people whispered a question they were almost afraid to say out loud. What happens to the world when reaching orbit becomes cheap? The 90s were filled with optimism. An era when science felt unstoppable. The International Space Station was taking shape. Mars missions were launching. Private aerospace was emerging. And the X-33 was supposed to be the bridge into a new space age. Construction began at Lockheed's Skunk Works, the legendary factory behind the SR-71 and the U-2. If anyone could make a sci-fi spacecraft real, it was them. Engineers built the frame. They tested the engines, they produced prototype tanks, they ran simulations, they welded panels. Piece by piece, the future was coming together. But the deeper the engineers went, the more they realized something frightening. The technologies required were at the limits of what physics allowed at the time. The composite tanks cracked during testing. The AEROSPIKE engine needed extreme precision. The thermal protection system needed breakthroughs in material science. The mass margins were razor thin, too heavy, and the entire SSTO dream collapsed. The X-33 wasn't merely a challenge, it was a knife edge between success and the impossible. And NASA had set a deadline that was brutally ambitious. In 1999, disaster struck. The massive composite liquid hydrogen tank, the heart of the entire vehicle, failed catastrophically during testing. Layers split, material delaminated, the tank tore apart. Without that tank, SSTO was dead. The VentureStar was impossible. NASA asked Lockheed if they could redesign it using aluminum. Lockheed said yes, but the new tank would be so heavy, the craft could never reach orbit. The math stopped closing. The dream fell apart. And behind the scenes, politics were shifting fast. Budget pressure increased. New NASA leadership questioned the entire program. Congress grew skeptical. The shuttle was still flying, and the ISS needed funding. The X-33 had gone from a symbol of the future to a symbol of uncertainty. And in 2001, after hundreds of millions of dollars spent, hardware built, engines ready, structures assembled, NASA canceled the program. The almost complete craft never flew, not even once. It was left in a warehouse in the Mojave Desert, a monument to a future that had slipped away. Years later, people looked back with a question that still stings. Was it canceled because the technology failed or because the timing did? Because here's the twist. Many of the technologies the X-33 needed, lighter composites, advanced simulations, modern manufacturing, exist today. The engineering barriers that stopped the program then might not stop it now. Even more ironic, private companies eventually achieved the future NASA abandoned. SpaceX made reusable rockets normal. Blue Origin developed vertical landing boosters. Aerospace startups work on reusable single-stage concepts. Modern materials can handle stresses the 90s couldn't. In other words, the world eventually built the future NASA tried to build first, just not in time to save the X-33. Some engineers now argue that if the program had held on just 5 more years, materials technology would have caught up. Instead, the project ended right before the world entered a new aerospace renaissance. The timing could not have been worse. The X-33 wasn't a failure. It was a prototype trapped between ambition and reality. Too advanced for the 90s, too fragile for its deadlines, too expensive for politics, but too visionary to truly die. Because the idea behind it, rapid, reusable access to space, is now the foundation of modern rocketry. Every landing booster, every reusable capsule, every autonomous launch system, they all echo the same goal the X-33 had. In its failure, it predicted the future. So what if the X-33 had flown? What if the tanks hadn't cracked? What if NASA had given the program 5 more years? What if VentureStar had replaced the Space Shuttle? Space could have become cheap a decade earlier. Satellite launches could have been a routine in the 2000s. Commercial spaceflight might have matured sooner. Mars missions might have been planned earlier. Private rocketry might have evolved differently or faster. Modern materials can handle stresses the 90s couldn't. In other words, the world eventually built the future NASA tried to build first, just not in time to save the X-33. The X-33 VentureStar remains one of NASA's greatest almosts, a machine that represented the future but arrived before the world was ready to build it. It showed what was possible, what was coming, what could have been, and what timing can destroy. The X-33 wasn't a failure. It was a prototype trapped between ambition and reality, too advanced for the 90s, too fragile for its deadlines, too expensive for politics, but too visionary to truly die. Because the idea behind it, rapid, reusable access to space, is now the foundation of modern rocketry. Every landing booster, every reusable capsule, every autonomous launch system, they all echo the same goal the X-33 had. In its failure, it predicted the future. This was Missed Futures, the series where we look back at the visions that came too early and the engineers who saw the future long before the world allowed it to happen. Subscribe for the next episode. The next lost future might hit even closer to home.
Program. Left position.